Hi, good evening everyone. So this is but now we are going to find out the transient response of an RL circuit with different standard test function. So I'm taking the applied voltage is V of t and the switch is opened at 0 minus and switch is closed at t equal to 0 plus. I have R, L which are connected in series. So I would like to transform this into an S domain. I'm redrawing the voltage source and this I'm writing it as V of S and the switch is closed at t equal to 0 plus and I have an resistor followed with an inductor. This is R, the units are in ohms, and this is L. You can write down this as a S L ohms. And I'm assuming the current of I of S is 1. Let's try to derive the equation of I of S and we'll try to apply for the different function. Whenever the current is entering, the entering terminal is positive, the leaving terminal is negative. And the current is flowing like this, entering terminal is positive, leaving terminal is minus. And the voltage source is nothing but plus or minus. Current is leaving, the polarity of the voltage is plus. I'm going to write down it as plus V of S. Current is entering it positive and current is leaving it negative. The leaving polarity is minus I into R. I value is I of S and the resistance offered is R. And current is entering at positive terminal, current is leaving at negative terminal. So I want to write down the drop. So the current in the series circuit, the current is constant. And what is the name of that current is I of S. So I'm writing it as I of S into R value. So R value is nothing but S L ohms is nothing but the algebraic sum of voltage source is equal to 0. So now here I require the value of I of S. So I am sending this I of S to right hand side. So therefore V of S I am going to get it as by taking I of S as common is this is R plus S L ohms. So but I require the value of I of S. So I can write down I of S is equal to V of S divided by R plus S L. But you see here, I should make the coefficient of S should be 1, then I have to take L as n common. So I'm going to write down this as V of S divided by taking L as a common, then you're going to get R by L plus S. Okay, so this is how the equation resembles. So if you want to shift it to the numerator, so this is L by 1, you can write down this as V of S into, here it is L by 1, you can write down the numerator as 1 by L divided by S plus R by L. So this is what the current equation I of S. If you remember this equation, then we can apply for all the standard test signals. Let's try to move forward. So let's try to apply the concept for an unit step. So we are going to find out the transient response of an RL circuit to unit step function. So already we defined the unit step function as u of s is equal to 1 by s. So the unit step function is saying u of s is equal to 1 by s. Now substitute where u of s is nothing but the input signal. So now we are going to have I of s is equal to, so this input signal is u of s, the input is nothing but you can write down this as 1 by s into 1 by L divided by s into, sorry, divided by s plus R by L. So now this I can write down, here it is 1 by s, let's come to the numerator, you can write down it as 1 by L divided by, it is 1 by s, when it comes to denominator, this is s into s plus r by l. You can see here, this still we need to solve this equation by using partial fractions method. So this I can write down as a, so I'm writing this equation as in the partial fraction form, 1 by l divided by s into s plus r by l, that is equal to, you can write down the partial fractions method as a by s divided plus b divided by s plus r by l. So this is how you can write down. So when you take it as common and taking the LCM for this is s into s plus r by l. So this is a into s plus r by l plus b into s. So when you compare these equations, you can get these terms as common and substitute s is equal to, let us substitute s is equal to 0. So when you make s is equal to 0, automatically b term will become 0. So when s is equal to 0, then you are going to get as 1 by l is equal to, when s is equal to 0, then you are going to get 0 by r by l. Automatically l will get cancelled out, and you are going to get the value of a is equal to 1 by r. Similarly, I want to make this term as 0, therefore you substitute s is equal to minus r by l. When s is equal to minus r by l, when you substitute in this equation, then you are going to get 1 by l is equal to a into 0 plus b into minus r by l. L will get cancelled and you are going to get the minus here, minus 1 by r is equal to b value. So successfully we find the unknown coefficients for this equation. Okay. Now let us try to write down the equation of I of s. So I of s after partial fractions method, we are going to get 1 by r divided by s minus of nothing but b value is minus 1 by r, minus of 1 by r divided by s plus r by l. So if you want to find out the transient response, I need to convert this s domain into time domain, apply inverse Laplace transform. When you apply the inverse Laplace transform, this is nothing but I of t. So I of t is equal to, so it's nothing but inverse Laplace of 1 by s, which is nothing but 1. So inverse Laplace transform of 1 by s plus a is equal to exponential of, here it is plus, automatically to the power minus 80. So here is nothing but 1 by r. So it's nothing but 1 by r. So 1 by s, the Laplace transform, we are going to get it as 1 minus of 1 by r. So 1 by s plus a can be written as e to the power 80 minus a. What is the value of a? Which is nothing but r by l into t. So I can call this equation as, so this is the equation of current. So it is nothing but the current, where this current is called response or output current. So this is the current response or the transient response of a series RL circuit for an application of its signal unit step signal. So this is how we proceed with unit step signal. Thank you. So if you feel comfort, continuously follow all the classes, then you can understand